is again a review. Solving linear equations should be like riding a bike to you, but I want to make sure it's like riding a bike, just in case some of you are still a little wobbly. So hopefully today will be pretty easy for most of you. And we're going to do a lot of participation where all of you will be at the board at some point today. We're going to do a lot of practice. Actually, you're going to be on your own board in a minute, but all right, here we go. Solving linear equations. You might ask why. Why do we have to learn this stuff? Why do we have to learn linear equations? Well, here's a problem that I'm just going to throw up here, but we're going to throw up. But we will answer it, come back and answer at the end of the block. The student has a debit card with a prepaid amount of $270 to use for school lunches. The cafeteria charges $4.50 per lunch. How much does he have left on his card after buying 5 lunches? That's a very practical question. And you don't even realize when you're answering that question that you're using an equation to do that. Your head is, whether it realizes it or not. So we're going to come back to this at the end of the block and write an equation for that situation. So let's first review how to solve it. You got to think about the whole balance scale thing, all right? The equal sign is in between. It's not showing up too good. Let's do a white here. Your equal sign is like the bar in between. And whatever is inside this bucket has to be equal to whatever's in this bucket. So if you take a 2 out of this bucket, then you got to take a 2 out of this bucket or it won't be balanced anymore. So always think about whatever you do to one side of the equal sign, you've got to do to the other. So for example, we have 2/3 x minus 7 equals 5. You tell me, and the goal is to get the x by itself, right? So what would you like to get rid of first? Good. So to undo or to get rid of a -7, I do the opposite of that. So I'm going to add 7 to both sides. And form is huge, guys. You need to follow this form because by the end of this semester, you'll be doing much more complicated problems. And if you don't have some kind of form going on, it'll blow you out of the water. All right, now I want to get rid of this 2/3, and I am multiplying here. But I want just a 1x. How do I turn a fraction into a 1? Remember? Excellent. Multiply. You can divide. You can divide by it, or it's easier to multiply by the reciprocal. And of course, if we're going to multiply by the 3/2 on that side, we got to come over here and multiply by 3/2. And when you're multiplying, those cancel, so I end up with a 1, which is what I wanted, a 1x. When you have a whole number, sometimes it's easiest to go in and put a 1 under it to give you some visual of where the numerators and denominators are. Because we can cross cancel here. 2 goes into 2 once, 2 goes into 12 6 times. And now I'm left with 6 times 3 is 18. 1 times 1 is 1, but 18 over 1 is just 18. So 18 is our answer. I don't know how to do that right, hopefully. Okay. What if we have a variable on both sides? I'm going to try to show you one of each type. What if we have variables on both sides? We have 7 ponies plus 13 equals 9 ponies minus 5. We want to get, eventually we want p equals something, right? So usually kids like to put get the p on the left-hand side, because you're going to have to do that eventually anyway. But really it doesn't matter, because even if you get like 3 equals p at the end, you can rearrange those if there's an equal sign and turn it into p equals 3. So whether or not you put all the p's on the left side or all the p's on the right side, it doesn't matter. You'll still get the same answer. Okay? So what I'm seeing, I don't like to work with negatives. So I think I'm going to subtract 7p from both sides. But you might want to subtract 9p from both sides. Either way, we will get the same answer. What shall I get rid of next? Okay. Instead of undo a -5, I'm going to add 5 to both sides. And again, make sure you're doing form. Here's a multiplication by 2p. Instead of undo multiplying by 2, I'm going to divide. Very good. Right, you know this stuff, huh? So this is what I'm talking about here. You're going to get 9 equals p. Well, you can't leave it that way because you need to have p on the left-hand side. But since these are equal, I can just switch them around. It won't make any difference. So 2 equal 9. Questions? Okay. What we're going to do, let's do one more like this. It's a little more complicated. And then I'm going to let each of you have your own whiteboard, little blackboard things. And I'll call a group of you to do it on the board, and the rest of you will do it on your own board at your desk. And we'll take turns going up in groups to do problems. Okay? All right, so let's work this one together. First, what's the first thing I'm going to need to do in this problem? The D word. No, need to distribute. I need to distribute here. And I also need to distribute here before I start combining anything or moving anything around. So this is really 8x minus 4 times 36, right? Ooh, that's going to be a plus 3x, so it's a negative 3x. Now, here is a very common problem that kids do. Kids see this 5x and 8x and go, oh, I'm going to subtract 5x and I'm going to subtract 5x. What's the problem with that?
They're both in the same sign.
Yeah. See, this, here's your equal sign right here. This is the divider. So what you've done is you've subtracted subtracted 5x twice on one side. Well, that's really going to make you unbalanced. Can't do that. Instead, what do we do to the 8x and the 5x? Yeah, good. We combine them. We don't get rid of them. We combine them, put them together. So 8x plus 5x, what's that, 13x? And if you find it helpful to literally draw a line where your equal sign is, that is perfectly fine. All right, now I can get the x's together on one side. So I'm going to subtract 3x from both sides. And now I'm going to add 36. Got a positive and a negative, so I need to subtract those two numbers. Keep the sign of the larger. And 6/10 will reduce 2. Goes into both of those numbers. 2. So I'm coming up with 3/5. Confirmation on that? All right, good. Okay, so I'm going to, I'm going to pause this a second. So at this point, we're doing a lot of practice problems. Do y'all remember what any of these were? Anybody keep them written on your boards? So if you're at home, try these at home. See if you can get them. We did them all in class on the boards. And we did awesome. What we got here? This was a little tough because we had fractions, but we persevered. All right. It takes you 45 minutes to mow a lawn. It takes your brother 30 minutes. How long will it take if you work together? Very practical question. Quite thoughts? How we would set this up or what you would do? What would be your guess? Maybe subtraction? What time, if it took 45 minutes for you, 30 minutes for your brother, estimated wise, how long would you think it took? What's that? 25. Somewhere between 45 and 30, right? It shouldn't be as much as 45 or your brother's not doing enough. So it's somewhere between 45 and 30 minutes. So let's see. this is the way I kind of think of it. I'm gonna do kind of set up a ratio of the job over minutes, just to keep my mind kind of going on what I'm doing. So I can do one whole job in 45 minutes. My brother can do one whole job in 30 minutes. If we work together, then we will do one whole job in how many minutes? And this is what I'm looking for. Actually, I'm going to put an M there just to be different, an M for minutes. So this is what I really need to solve. So one job in 45 minutes plus one job in 30 minutes equals one job in how many minutes? So what do I do over here, ladies and gentlemen? Yeah, common denominator. Oh man, it's big. Calculators were needed. Are you serious? Did you multiply them together?
Yeah.
Oh gosh. 1,000 what?
350.
350. Woohoo! So this must be 30 then. If you multiply the bottom by 30. So this one must be what? 45, yeah. Thank goodness for calculators, huh? So I'm going to keep my common denominator. 30 plus 45 is that 75? No? Is it 75?
Yeah.
Now here's an example of what some of you were trying to do earlier. Notice there's an equal sign here. I have a fraction equals a fraction. This is where you can cross multiply. So I'm going to go m times 75 is 75m. And 1 times 1350 is 1350. If you have an equal sign between them, that's when you cross multiply, because that's a ratio or proportion. And then, of course, I'll divide by 75 and be grateful that we have calculators. And how many minutes did you come up with? How many? 18. All right, so you're close on the 20 minutes. And remember, on a word problem, you always need to label your answer with a word. All your standardized tests that you'll take, MAP and all that stuff, they want, or EOCs you take, they'll want some labels. Okay. All right, we're going to go back real quick and just real quickly write an equation for that very first lunchroom thing. Where was she? Right here. All right, let's see what happens here. So we have a debit card, has a prepaid amount of $270. The cafeteria charges $4.50 per lunch. How much does he have left? Okay, how much does he have left? What operation does that make you think of? Addition, subtraction, multiplication, or division when you talk about how much he's left? Subtraction, yeah. Okay, so we started with $270, right? I need to subtract some amount. I want to know how much he has left. Well, he's bought 5 lunches, and each of those lunches is $4.50. So what would I do with the 5 and the 4.50? Good, multiply. And that will be how much money, I'm going to put equals L, so how much he has left. There's my equation. So let's just solve that bad boy. I have no idea what is that on your calculators. What is it? 2250. How much she has left, and when you subtract it, baby, he's rolling in the dough still. Leftover. Okay. Everybody good with that? All right. Hopefully this was just a refresher lesson. If you would, the people who did not pick up boards last time, pick them up. And, oops, you'll need your book for your assignment today.